Hey, welcome back to day 7 of the 2023 Advent Code walkthrough. Today we are playing a little bit of camel poker, apparently. So in this problem, we are given a list of hands made up of 5 cards, very similar to playing cards. You know, we got values ace, king, queen, jack, don't know what the T is, all the way down to 2. And we get 5 cards, and those cards form a hand, and hands get ranked based on how good they are. Very similar to poker. They get ranked, 5 of a kind, 4 of a kind, full house, etc., etc. I guess there's no 5 of a kind in poker because there's only 4 suits, but you get the point. So we got to get through all of those, and our input file is a series of hands and a series of bids. Now our job is to sort this list from worst hand at the top with rank 1 to best hand down the bottom with rank, depends on the length of the file. And our score is the rank multiplied by the bid. We sum all of those values together, and that gives us the total winnings. Now, our puzzle answer for part 1 is 248836197, but let's have a look at how we get there, shall we? So diving into this, here's the code for day 7. Starting at the top, we define an enum, which categorizes the various types of hands that we can win. These are in order of highest to lowest, and we make use of that later on. 5 of a kind, 4 of a kind, full house, which is 3 and 2. 3 of a kind, 2 pairs, 1 pair, or a high card. Now, I should note that this is the order of the hands. If you have 2 matching hands that you have to rank, you look at them card by card, and you rank them based on the individual cards. Each card can be higher or lower than the other, and you keep going through until you find a mismatched card, and that determines the final ranking. We then have a structure here, which we define as a hand, which stores the string representation of the cards, the resulting category from that enum above, and the bid from the data file. We have a function here, hand to category, which maps a string representation of a hand to a hand category enum. It uses a hash map to loop through all the characters in that hand and store a count of how often each character appears. Now, characters in this case represent the different cards. You might have a 2, a 3, a T, a J, and it stores them in a hash map. This line here about J count and nulling the J, that's all to do with part 2, so just pretend that doesn't exist anymore. Pretend J count is always 0. What we then do is we grab all of the counts, all of the different numbers of cards that we gathered. Doesn't matter which is which in terms of our ranking. We sort them, and then we reverse that list. So we have, let's say we had 5 queens. This will be one single value, which is 5. If we had 4 queens and a 2, this would be then 5, 2. We then look at the highest value in our sorted list. If it was a 5, well, then there's only one possible outcome. It's 5 of a kind. Similar with 4. When we get to 3, we have a couple of different scenarios. We might have the second value be 2. So we've got 3 of a kind and 2, a pair. That's a full house. Otherwise, it's just 3 of a kind. Then if the highest value we found was a 2, we either have a second 2 for 2 pairs, or we have 1 pair. And if we didn't match any of those scenarios, we just have a high card. So with this function here, we can take any of the hands that we're given and map them to an appropriate category. And as I said, we'll come back to the J count in a little bit. The next thing we do here is really take advantage of Rust's trait system. We define partial ordering here, which is not particularly interesting. It just makes use of the full ordering function. And then down below, full ordering for the hand structure that we defined above. Before we can implement ordering completely, we need this other function which ranks cards. And all this does is it stores a list of the cards in lowest to highest order. J normally sits here between the T and the Q, but for part B we had to move it down to the beginning. It finds the card in the list and returns a numeric value representing of where that is in the list. It does technically return 99 if there's a character that doesn't match, but for the purposes of this puzzle, that's never going to happen, so we didn't worry about that too much. Then to implement the final ordering trait, which will allow us to do some handy things with a list of the hand structures, we first do a check to say, look, are the two categories of the hands that we're comparing exactly the same? So let's say we've got three of a kinds. We then need to loop through both hands card by card and do a ranking to find the overall winner. If the characters are the same, we just keep going. But as soon as there's a difference in the characters, we return how one character compares to the other using our card rank function above. If we get all the way to the end of the hand and they are truly equal, we just say that they're equal. Otherwise, we take advantage of the fact that enums have an ordering determined by the order in which the values are defined, and we compare one category to another. So having implemented this trait, this ordering trait, if we have a list of hands, we can use built-in sort functions to then get a sorted list of hands, in our case, sorted by ranking. And by doing this, it actually makes the rest of the problem relatively straightforward. So let's take a look. We start here again, parsing our input file into a string. We have an empty vector of hands that we're about to fill up, and we loop through every line in that file. We skip over empty lines, because occasionally when I copy and paste, I add an extra empty line at the end. And then we parse the line. We split it in half. We know that it's going to be a hand and a string value, but we do a little assert here to be sure. The hand is the first half, so that's the 5 characters that make up the cards. And then the second part is the bid, which we parse into a 32-bit integer. We then form a new instance of a hand structure, putting the cards, the category through our mapping function, and the bid into that structure, push it onto a list. Once we've done that, we've parsed all the hands. We can take advantage of the fact that we implemented the sorting trait, sort that list, and then start to loop through. So we know everything is in order at this point. We have a placeholder for the total number of points. We loop through the list in reverse, because remember, best hand gets the lowest or the highest numeric rank, and we enumerate through. We add to points with the current value of I, which is the ranking, plus 1, because enumerate starts at 0, times the original bid, sum all that together, and that's our total ranked points. So I like this one, and I like that it was done in Rust in our case, because it really shows just how much you can get done by implementing a couple of key traits, and this was a really nice example of that. Let's come into part 2, which made things a little bit more complicated. But again, thanks to the power of these traits, we didn't have to do too much to get part 2 done. The difference in part 2 is that J's, instead of being jacks, are now jokers, and they're wildcards in terms of determining the hand. We can substitute them for any card that we want when determining the hand. So if we've got, say, 3 queens and 2 jokers, we can call that 5 queens. But if we're comparing card by card, the joker is now the weakest individual card. So it would always lose if we were just dealing with a high card. So now, other than that, all the rules are exactly the same, but we can substitute jokers in where we wish. So let's have a look at what we had to change there. In the end, not too much. We noted before that we changed the ranking function to put the joker right at the beginning of the list. Normally it's in here between T and Q. The other thing we do here is we extract the number of jokers that we found from our hash map, from our counts, and then we set that to 0. So we just don't count them as individual cards. But everywhere that we're doing checks to say how many of the most popular card did we have, we substitute in J count. And that allows us to have much higher numbers for, say, 3 queens plus 2 jokers being a 5 of a kind. So with that small modification, we update our ranking function, and then otherwise we make no changes to the rest of the body of the function. We're still relying on the fact that the trait was implemented to sort our list, and that ultimately gives us a very quick and what I think is quite an elegant solution to the day 7 problem. So doing all that, coming back to day 2, our total score is 251195607, and that gets us a second gold star for day 7. I hope you're enjoying this series. I hope you enjoyed this video. If you did, please consider subscribing, leaving a comment below. Otherwise, I'm Elliot, I build stuff, and I will catch you in the next one.